Okay, getting ready for 6.2, lesson 6.2 on special products. I had you start by multiplying some of these, so if you haven't multiplied them, go ahead and do that now. And then we'll talk about how do we multiply two binomials. What do we have to make sure we do? FOIL. So first is going to be outside, inside, last. Okay, can you simplify anything here? Right, so this right here, these are like terms because they both have, you owe 10x's, you have 10x's, they both have variable of x to the first power, so we have 4x squared minus 25. So essentially these two binomials, they look exactly the same, but what's the only difference here? The signs, which means that the middle term is going to end up canceling out. Okay, because they're going to be the exact same numbers with different signs, and you're going to notice you have a negative. We call this right here the difference of two squares. Okay, why squares? Well, 4 is a perfect square, x squared is a perfect square, 25 is a perfect square. What is a perfect square? Yeah, because if I have 5 and 5, 5 times 5 is 25. Literally, that's the area of a perfect square, right? Perfect square has all four sides the same. If we multiply 5 times 5, we get 25. Can you think of any other perfect squares? What are, list for me all of the perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 16, 25, 6 times 6, 36, 7 times 7, 49. Okay, if I had a times table chart, which I didn't bring, you'll see that it's the diagonal, 64. Okay, these numbers go on for infinity, right? They can continue. We're just multiplying. What 64 is what times what? 8 times 8. Okay, now here, when you square a binomial, that's what we were talking about in section 5.5. What do I have to do if I square this binomial? I have to make sure that yes, I multiply, when I square something, I multiply it by itself. So here, again, in order to multiply it out, I'm going to also have to FOIL. So 2x times 2x is plus 10x plus another 10x plus 25. Now when I simplify that, what happens to the middle term? Yeah, I have two of them. So I have 4x squared plus 20x plus 25. This, what we call this, is a perfect square trinomial. Okay, what is going to happen if I multiply? If I square a binomial, I always have to remember to multiply it by itself. Squaring something means I multiply it by itself. Yes, so I have 2x minus 5 times 2x minus 5. What do I get there? 4x squared. So I'm going to have two. Are they going to cancel each other out if I have two negative 10x's? How many 10x's am I going to have? Negative 20x, because I have two negative 10x's. Plus 25. Notice because they're both negative, here that last term is positive because a negative times a negative gives me a positive. So again, PST, perfect square trinomial. PST stands for perfect square trinomial. Why am I calling it a trinomial? Yep, 3 terms. 1, 2, 3. Are any of these terms alike? No, because they all have x squared. That's not like x. That's not like no x, right? Okay, now what about this one? x plus 3, x minus 3. When you FOIL it out, what do you get? Plus 3x minus 3x minus 9. So if I combine my like terms, what happens to the middle? 0. So I get x squared minus 9. Do I call this a perfect square trinomial? No. Because how many terms are there? 2 terms. So difference means subtract. Difference of 2 squares. X squared is a perfect square because it's x times x, right? Why is 9 a perfect square? It's what times what? 3 times 3. So both of these are perfect squares. The subtraction in the middle, because you had 2 different signs, right? What would you get if you square x plus 3? Please don't tell me it's x squared plus 9. Please do not tell me that. Why isn't it just, I thought it would just be x squared plus 9. Where are we getting, you're saying it's x squared plus 6x plus 9. Why is there a 6x in the middle? Yes, because remember we have the outside and the inside, the oi. Outside, inside is oi, right? So we have the middle term. What's this one going to be? X squared negative 6x plus 9. Does everybody see how we got this answer here? You would have to take x minus 3. Whenever I square something, I multiply it by itself, right? First, outside, inside, last, right? FOIL. Okay, so it's just a little review from chapter 5, leading us into special products. So far we have seen how to factor out a GCF and the related technique for factoring by grouping. Today we're working on a couple more techniques for factoring. For the most part, this will involve trial and error with an eye for some patterns. But here's one particular case that's worth remembering. So this is we were just talking about the difference of 2 squares. The difference of 2 squares looks like this. This is difference of 2 squares. Okay, dot. And I use the word dots. Difference of 2 squares. Well, one of my students made it up and I liked it. Dots, it sticks, okay? So the difference of 2 squares, a squared plus b squared, or minus b squared, is going to factor into a plus b times a minus b. So what I want you to realize is if we look at this first problem, the reason why I gave you this first problem is it's an example of difference of 2 squares. So if I have 4x squared minus 25 and I want to factor it, remember we multiplied these 2 binomials to get this answer, right? We multiplied. When we factor, we want to figure out, well, what did I actually multiply together in order to get this? So if I go, what times what gives me 4x squared? 2x times 2x gives me the 4x squared, right? What times what gives me 25? 5 and 5, but it's negative. So what do the signs have to be? One is positive, one is negative. So when we multiply these, when we FOIL them, we get that. When we go backwards, we want to factor. We factor this, we get we want the 2 factors that we multiplied to get that. That's the difference between going this way is factoring, going this way is FOILing, right? So that's why, factoring versus FOILing. FOILing is multiplying. They're really, you're just going round and around and round. Does that make sense? Okay, this is a very useful technique for factoring binomials, but only if they're difference of 2 squares. dots. Difference of two squares. Identify each term as a perfect square is important here. Identifying. Try the following. Okay, so if we square the numbers. 1 squared, 1 times 1, what's the squared number? 1. Oh, this is the squared number. Sorry, that's not squared. Okay. Oops, I didn't mean to put it there. Okay, the square number is 4. 2 times 2 is 4, or 2 squared. 3 times 3 is 9. Next one in the pattern would be 4 times 4, 16. 5 times 5, 25. 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13 is 169, 14 times 14, otherwise known as 14 squared, right? It's 196. Does anyone know 15 squared? I do, 225. Okay. 16 squared is 256, 17 squared, 289, 18 squared, I think it's 324. Anyway, I'm just showing off. 220 squared is 400. All right. Identify each as a perfect square and write it as such. 9 as a perfect square is the same thing as 3 squared. 16 we know is 4 squared. What would I have to do? What would be the exponent on the x? Sorry, I didn't push up the paper. What would the exponent on the x be in order for us to get a 6 here? Cube, right? To the x to the third squared would be x to the 6th. That's chapter 5. What would I have to multiply by itself here? What squared would give me 4x squared? 2x. Yes? 2x? Uh-huh. Yes, yes, because they're both in parentheses. Okay, I'm going to put a number in parentheses. I'm going to square it. What number is going to give me this? 9. 9 squared is 81. X squared squared is x to the 4th. Y to the 4th power. Okay, so we're just identifying what would be the perfect square. Write it as such. That's what we're doing. What number did we have to square? Okay, this is the first step in using the difference of squares formula. Once you've identified both terms as a perfect square, we can apply the formula. So when we're doing this, when we're factoring, we're going to get two binomials. We want to know what two binomials do I have to multiply together to give me x squared minus 16. So what number times itself gives you x squared? X, right? And then the signs, because this is negative, we need a negative and a positive to get that negative sign, right? What times what gives us 16? 4 and 4. Now, if you want to check, how would you check to see that I factored? This is right here called the factored form. Factored. How would you check this if you want to know if it's correct? You would want to FOIL it. So you can check by FOIL. X times x gives us x squared. Positive 4x, negative 4x is 0, right? Negative 4 times positive 4 is, yes, negative 16. So it worked. I just did a mental FOIL. I didn't write it down. Who thinks they could tell me the factors for this one? 1 minus 5. Okay, good. What about here? Oh. 10x minus 7, 10x plus 7. Does everybody see how she got that? Why 10x times 10x? Yes, 10 times 10 gives us 100. The signs are opposite. Now what about D? Mm. Yes, so actually we call this prime. Prime meaning it is not factorable. Okay, and that's because of the positive sign. The only way you could get that positive sign, you would have to have the same signs. But if you had the same signs, you would have a middle term. Like notice what we had back here. When we had the same signs, right, we have a trinomial. When we multiplied 2 with the same signs, here we had the same signs, we get a trinomial. So the only way to get a positive is with same signs, and that's going to give you a trinomial. You could actually try writing the factors and multiplying it out. Here we have difference. It's always going to be subtraction of 2 squares. So who can tell me what is the first part? 7m, because 7m times 7m gives you 49m squared, yeah? Tell me about the signs. Plus and minus. Does everybody see where we're getting this A here? Yeah? What do you want to do about this one here? Okay. Does everybody see where we're getting 7a? Right? Positive and negative gives us the negative sign. X cubed y squared. They have to be a perfect match, right? Because a number times itself. X cubed times x cubed gives you x to the 6th. Y squared times y squared gives you y to the 4th, right? Any thoughts about this one? So x squared times x squared gives you x to the 4th, right? Minus 9 plus 9 gives you the negative 81. Now, is either one of these still factorable? Which one? Yeah, because that's 9x, or I mean, yeah. This one is going to be prime right here for the same reason that that's prime. Okay, because of the plus sign. But because you have difference of 2 squares, you're going to have x plus 3, x minus 3. Do you see where we're getting x plus 3, x minus 3 from the x squared minus 9? And then this one right here does not factor. Okay, now the last one says hint, factor out the GCF first. So we're always going to want to do that first. We're looking to see, is there anything that they have in common? Because 12, notice 12 is not a perfect square, correct? Is 27 a perfect square? Is x a perfect square? No. So it has to be a number times itself. So is there a GCF that goes into everything? 3 and x. So we're going to divide both of them by 3x. That's the GCF. So 3x is the GCF. When you factor out 3x, what do you get? Okay, minus 9. Is this a difference of 2 squares? Can it factor? What do you get? Minus 3 plus 3. Okay, we're going to stop this and